So, the other day I was in Dublin and I went to this place that people recommended me a lot, Dices. However, the point is not about that I went there, but is that I got my phone stolen. So as soon as I realized that, I was like, I need a new phone. You know, I need to know what's going on with everyone. I just felt disconnected. So I went straight away to Amazon to get a new phone. And honestly, I didn't know which phone to get, so I started looking for different brands. And after informing myself about the different brands, I was like, I need to go to sleep and I need to decide wisely. What happened next was the thing that impressed me the most. So the next day, I went again to Amazon, and suddenly, my account was full of recommendations of mobiles and accessories. And I just didn't understand how this happened. I ended up buying everything, of course. I just thought that I needed all of that. It was like if everything I needed was there on the main page. I even got a PS4. I just didn't understand how this happened. So I went with my mates to talk about it, and well, they didn't understand either. So we decided to get to know more about this, and this is what we found out. So first of all, to understand big data and big data analytics, we have to start from scratch. What is big data? So big data is the term used to define large amounts of data that can be processed. And big data analytics, on the other hand, is the study of all this stored data in order to reveal behavior patterns, trends, and associations. The earliest records of using data to track and control businesses date back to 7,000 years ago, when accounting was introduced in Mesopotamia. Data has been an essential part of human evolution for thousands of years, to total observation and understanding. We process the data to either complicate or simplify our lives as our brains evolve over the centuries. The capacity to assimilate large amounts of data became an integral part of our existence. Today, with our advanced technology, machines have become capable of acquiring and processing such large sets of data. Big data is characterized by the velocity it is generated, the huge volume, the variety of typology. For example, if it is a text, an image, a video, an audio, and the veracity. These characteristics are known as the 4 V's. The amount of data we produce every day is truly amazing. There are 2.5 quintillion bytes of data created each day at the current pace. But that pace is only accelerating with the growth of the Internet of Things. Over the last 2 years alone, 90% of the data in the world was generated. But how is all this information processed? Well, in year 2005, Yahoo created the open source framework Hadoop with the intention of indexing the entire World Wide Web today. Hadoop is used by millions of businesses to go through colossal amounts of data. Amazon, Netflix, Starbucks, American Express, Spotify are some of the top-tier companies handling big data today. So now that we understand a bit more how big data works, I'm going to call my colleague. He's an expert. He's going to show you how it is collected, how it is processed and analyzed.
So I thank my friend for calling me an expert though. So now let us understand how Hadoop works. So the traditional approach, which you can see earlier, the traditional method was followed. So in a traditional approach, usually the data that is being generated out of the organizations, the financial institutions such as bank or stock markets and the hospitals is given as an input to the ETL system. An ETL system would then extract this data, transform this data, and then convert this data into proper format, and finally load this data into the databases. Now, the end user can generate report and perform analytics by querying this data. But as this data grows, it becomes a very challenging task to manage and process this data using the traditional method. This is one of the fundamental drawbacks of using the traditional approach. Now let's try to understand some of the major drawbacks of using the traditional approach. The first drawback is it's very expensive and it requires a lot of investment for implementing and upgrading the system. Therefore, it is very difficult for small sized companies to use it. The second drawback is scalability. As the data grows, expanding the system is a challenging task. And the third drawback is it is time consuming. It takes a lot of time to process and extract such valuable information from the data. I hope you have understood the traditional approach of storing and processing big data and its associated drawbacks. So how large companies handle and gather big data? So they use a database called Hadoop. So Hadoop is an open source framework developed by Dow Coding in 2016 and it is managed by Apache Software Foundation. Hadoop is designed to store and process huge volume of data efficiently. How does Hadoop work? Well, Hadoop comprises of two main components. The first component is the HDFS, and the second component stands for the MapReduce. The HDFS takes care of storing and managing the data within the Hadoop cluster, whereas the MapReduce takes care of processing and computing the data that is present within the HDFS. Now, let us try to understand what actually makes up a Hadoop cluster. Well, a Hadoop cluster is made up of two main nodes, which is right here. So, the first one is the master node and the second one is the slave node. The master node is responsible for running the name node and the job tracker daemons. For your information, node is a technical term used to describe a machine or a computer that is present within a cluster. And daemon is a technical term used to describe a background process running on a Linux machine. The slave node, on the other hand, is responsible for running the data node and task tracker daemons. The name node and the data node are responsible for sorting and managing the data, and they are commonly referred to as a storage node. Whereas the job tracker and task tracker are responsible for processing and computing the data, and they are commonly referred to as compute node. Usually, the name node and job tracker are configured and run on a single machine, whereas the data node and task tracker are configured on multiple machines. But we can have instances running on more than you can say one machine at the same time. So the Hadoop framework comprises of Hadoop distributed file system and MapReduce framework. Let us try to understand how data is managed and processed by Hadoop framework. The Hadoop framework divides the data into smaller chunks and stores each part into a separate node within the cluster, which is right here. So let's consider you have 4 terabytes of data and a 4 node Hadoop cluster. The HDFS would divide this data into 4 parts of 1 terabyte each. By doing this, the same time taken to store this data onto the disk is significantly reduced. The total time taken to store this entire data into the disk is equal to storing one part of the data, as it will store all the part of the data simultaneously on different machines. In order to provide high availability, what Hadoop does is it would replicate each part of the data into the other machines that are present within the cluster, and the number of copies it will replicate usually depends on the replication factor. By default, it is set to 3. If we consider the default replication factor is set, then there will be 3 copies of each part of the data on 3 different machines. So in order to reduce the bandwidth and the latency time, it would store 2 copies in the same part of the data and the node that are present within the same rack, and the last copy would be stored on the node that is present on a different rack. Let us say node 1 and node 2 are on rack 1 and node 3 and node 4 are on rack 2. Then the first 2 copies of part 1 will be stored on node 1 and node 2, and the third copy of part 1 would be stored either on node 3 or node 4. The similar process is followed by storing remaining part of the data. Since the data is distributed across the cluster, the HDFS takes care of networking required by these nodes to communicate. Another advantage of distributing this data across the cluster is that while processing the data, it reduces a lot of time. Hence, this is what big companies use. Time is all about money. Hence, Hadoop is that is how Hadoop is different from its competitors. like the Snowflake, MapR, IBM Analytic engines, and DataMeal. Now that the big data is in process, it is time to analyze the data and build strategies accordingly. Hence, I would call my friend to explain you about how Amazon and other companies use this process data.
Just to put a little bit more in context, let's say the big data is the whole garbage generated, and Hadoop is the recycling company transforming all the data into important segmented information, which can help the development of strategies in relation to global marketing. Take as an example Amazon, one of the biggest retailers company in the market nowadays, and how they use 4 types of big data analytics. The first type of big data analytics is descriptive analytics. It's the interpretation of historical data to better understanding changes that have occurred in the business, for example, trends. An example with Amazon would be the A9 algorithm, which is the system that Amazon's use to decide how products are ranked in research results. The A9 algorithm also puts a strong emphasis on self-conversions. Therefore, Amazon will rank listings with a strong sales history and high conversion rate more highly. That means products which are highly ranked are more likely to receive more traffic and thus have better chance to achieve high sales. In turn, this will boost in the ranking and so on. The second one, the second one is diagnostic analytics. It's the form advanced analytics that examines data and answer the questions, why did it happen? Focus on the causal relationship and sequences, for example, seasons, events, or holidays. Let's say St. Patrick's Day and the demand in, I don't know, green or leprechaun accessories. Continue with the main or the most important for Amazon, the predictive analytics. This is the most common used technique. Predictive analytics use models to forecast what might happen in specific scenarios. Examples include next best offers, or how does Amazon use this? It does by the anticipatory shipping model. Amazon's patented the anticipatory shipping model uses big data for predicting the products that you are likely to purchase, when you might buy them, and where you might need the products. The items are sent to local distribution centers or warehouses, so they will be ready for shipping once you order them. Amazon uses the predictive analytics to increase the product's sales and profit margins, while decreasing the delivery time and overall expenses. Prescriptive analytics, the most valuable and most underused big data analytics technique. Prescriptive analytics gives you a laser-like focus to answer a specific question. It helps to determine the best solution among a variety of choices, given to know parameters and suggest options for you. How to take advantage of the future opportunity or mitigate future risk. It can also illustrate the implications of each decision or improve decision making for you. Amazon's used this by its personalized recommendation system, which of course is built on the big data and gathers from millions of customer transactions. Put something that someone might like in front of them, and they might well be overcome by the burning desire of buy it, regardless of whether or not it will fulfill any real need. Next, my colleague explained the relationship of big data analytics and global marketing.
Amazon started to use Hadoop and other technologies in big data in order to increase their sales. As a result, since 2009, they have increased their sales aggressively. In 2009, the total amount of sales was 25 billion. The company since that increased amazing 850%, achieving in 2018 the amount of $233 billion. How do we link big data with global marketing? Let's put into practice everything that we have learned so far, using the example of the iPhone. Using all the big data collected and processed, the website will analyze the best and profitable way to show the results for you, advertising an accurate model, color, and memory. For that, avoiding the risk of losing the customer interest. Also, at the same time, they use all the data collected to advertise similar products that have been purchased together with the product chosen, increasing the chance of acquisition and at the same time, the amount of products in your bag. Thanks to the big data analysis system, Amazon makes 35% of their profit by recommending additional products. Amazon also used that system to get profits from the ones who post the products in the website, by charging extra money in order to highlight the products. In other words, if I want to invest in my product, I have the option to pay extra fees, and as a result, my product will be advertised and appear at first when searched by the keyword. Amazon achieved some standards after start to make use of big data as a support for their advertised sales. As a result of that, 70% of Amazon customers never click past the first page on search results. 35% of Amazon shoppers click at the first product shown. The first 3 items displayed in search results accounted for 64% of the clicks. It shows how accurate and worth it is the process of data analysis. As you can see, Amazon has a very accurate system who provide the right product for the right person together with the right complement product. You might never thought about it before, but now your perspective about the online service and how you browse on internet is going to be totally different. The access of big data, low-cost commodity hardware, new information management, and analytics software have produced a unique moment in the history of data analysis. The convergence of these trends means that we have the capability required to analyze astonishing data sets quickly and cost-effective for the first time in history. These capabilities are neither theoretical nor trivial. They represent a genuine leap forward and a clear opportunity to realize enormous gain in terms of efficiency, productivity, revenue, and profitability. The age of big data is here, and these are the truly revolutionary times for big data analytics and global marketing. Thanks for watching. Hope this talk helped you understand a little bit more about global marketing.